Hi, and welcome to another past paper walkthrough. This is again from the Cambridge International AS and A levels papers. This is paper 1, pure mathematics, and it is from May-June 2022. And this is variant 1 of the pure maths paper 1. Okay, so again, rounding off is to 3 significant figures, or if we have angles and degrees, we round off to 1 decimal place. Again, in the description below, there will be timestamps for each specific question, so you can have a look at that to see whichever question you like to look at. All right, first question. Express x squared minus 8x plus 11 in the form x plus p squared plus q, where p and q are constants. So this is just completing the square. Now the first thing we want to do in completing a square is make sure the a value, or the value in front of the x squared, is 1. That's already the case, so we don't have to factor that out, otherwise we would have to. So what we can do is we can rewrite the first two terms, and then we're going to add and subtract half of this value squared. So half of negative 8 squared, so let me just write it like this, so we can see what's going on. So half of negative 8 squared, and then we're going to subtract that again, half of negative 8 squared, so we don't change the value of anything, and we still add our 11. And now the reason we do that, hence the name completing the square, is that this part makes a perfect square now. So that we can factorize into x minus, and then this value in the bracket. So 8 over 2 is 4 squared. Okay, and then we just calculate this part. So negative 8 over 2 is negative 4 squared is 16, negative 16 plus 11 is negative 5. And there we go. That is it. Okay. Hence, find the exact solution of this equation. Okay, so we know that this whole part can be rewritten as this. So x minus 4 squared minus 5. That's this whole thing written in a different form equals 1. Okay, so then we can take over the negative 5. So 1 plus 5 is 6. And then we take the square root of both sides, so x minus 4 is equal to plus or minus the root of 6, and then we can take over the 4. So x equals plus minus the root of 6 plus 4. Alright. Next up, question 2. Let's change color for this one. The 13th term of an AP is 12. Okay, so for an AP, let's do this. Let's say for an AP, we've got this formula, Tn equals A plus n minus 1 times D for the nth term. And for a GP, the nth term is A times R to the power n minus 1. And then the sum of an AP, so the sum of the first n terms of an AP is n over 2. So half the number of terms, 2 times the first term, plus n minus 1 times the common difference. Okay, so the 13th term, so that's where we can use this. So term 13 is 12. So 12 equals A plus n minus 1. So the 13th term, so 13 minus 1 times the common difference. Okay, let's rewrite this to get A by itself. So that'll give us that A is equal to 12 minus 12D. Alright, then next up we also have the sum of the first 30 terms is negative 15, so that's where we can use this one. So the sum of the first 30 terms is negative 15, so negative 15 equals 30 terms, so 30 over 2 times A plus n minus 1, so 30 minus 1 is 29 times D. Okay, so negative 15, this is 15, so negative 15 divided by 15 is negative 1, equals 2a plus 29d, oops, 29d. Okay, so now we can substitute this a value into this equation. So substituting that into that, we get negative 1 equals 2 times 12 minus 12d plus 29d. Okay, So let's multiply that in. So that gives us 24 minus 24d plus 29d. And getting all the d's by itself. So negative 1 minus 24 is negative 25 equals negative 24 plus 29 is 5d. And then divided by 5 on both sides, we get negative 5 is equal to d. Okay, and then we can substitute that back into here. So a is equal to 12 minus 12 times d, and d is negative 5. So that gives us a equals 12 minus minus, or plus 60. 12 plus 60 is 72. That's the a and the d value. And now we have to find the sum of the first 50 terms. So again, we can use this formula. So the sum of the first 50 terms equals 50 over 2 times a plus n minus 1, so 50 minus 1 times d. Alright, and that we can just type in the calculator. That's just 25, and 2 times 72 is 144, plus, well, that's actually going to be minus, and then 5 times 49 is 245. So that gives us 25 times, and what is this? Is that 99? 99. Okay, so that's basically just 25 less than 2,500. So, where's that? Negative 101. Wait, let me just get a calculator before I confuse everyone, including myself. Brain is not functioning at max capacity today. Minus 245. Negative 101. Negative 101. So that gives us, so times that by 25, that's negative 2525. Negative 2525. Alright, so that's the sum of the first 50 terms. This is a pretty good question. Basically, all of these all of these sequences and series question, well, a lot of them come down to just lots of simultaneous equations. So if you know your formulas, you'll be fine with all these. Just plug in the values in the formula, solve simultaneously, and get to your answer. Alright, next we have this one. So the coefficient of x to the power 4 in this expansion is a, and the coefficient of x squared in this expansion is b. Find a and b in terms of the constant k. Okay, so for 3 marks, there should probably be a quicker way than what I'm going to do, because the way that I'm thinking of looks like it's a bit more work than 3 marks. Basically, I'm saying this. I'm saying the r plus 1th term is equal to okay, well, let's start with this. Let's say we have a plus b to the power n. Then the r plus 1th term would be n choose r, a to the power r, and b to the power n minus r. So this is what we're going to use here. Okay, so we're going to say we're looking for the x to the power 4th term, the coefficient of that. So we're going to say it's n choose r. So n is our 5 here, right? That's our n. So n choose r, the first term, so that's 2x squared, to the power r. And then the second term, which is k squared x to the negative 1. So I just took the x up to become negative 1 here. And that's to the power n minus r. Okay? But now we want to separate out the x's. So let's rewrite this as 5 choose r. And then I'm going to write 2 to the power r. Then I'm going to write the, well, let's do the x's so long. So x to the power 2r. Then we've got k to the power 2 times 5 minus r is 10 minus 2r. And then we've got x to the negative 1 to the power negative r. And sorry, 5 minus r. So let's just multiply this in straight away. So negative 1 times 5 minus r is going to be r minus 5. R minus 5. Okay, so let's collect these two x's together. So our whole coefficient is going to be 5 choose r, 2 to the power r, and then k to the power 10 minus r, and then all the x's together. It's going to be 2r plus r minus 5, so 3r minus 5. 3r minus 5. But we're looking for x to the power 4, the coefficient of that. So that means this coefficient must be the same as this coefficient, right? So 4 must be equal to 3r minus 5. Let's take over the 5, so 9 equals 3r, divide by 3, 3 equals r. So now we can just substitute the r with 3 in our coefficients. So we're going to have 5 choose 3, 2 to the power 3, k to the power 10 minus 3, so that's 7, and then x to the power 4. Okay, so this is our coefficient. Now we just need to solve this. So 5 choose 3, I'm not sure what that is, so let's get a calculator out here, a better one than what I have. So let's do 5 choose 3. Oops. 5 choose 3. And let's see how much that is. It's like 6 or 8 or 10, somewhere around there, I think. So 10. Okay, so that's 10. 2 to the power 3 is 8, so 10 times 8 is 80. So 80k to the power 7. Is that right? 7 seems... Where did I do something funny here? K squared. So 10 minus 2r. Sorry, 10 minus 2r. I forgot the 2 there. Okay, so that's not going to be 7. That's going to be 10 minus 2 times 6. So 10 minus 6 is 4. Okay, so that's going to be a 4. So that is what A is equal to. Alright, now we can do the same for B. So again, we have the r minus 1th, or the r plus 1th term. So we're going to say that's, and our n in this case is 4. So we've got 4 choose r. First term, which is 2kx to the power r. And then the next second term, which is negative 1 to the power n minus r. Okay, but, okay, let's again just multiply out so we get the x's by itself. So 4 choose r, 2 to the power r, k to the power r, and then negative 1 to the power 4 minus r, and finally we've got x to the power r. Okay, but we're looking for x squared. So x2 must be equal to r. So 2 equals r, and then we can just replace the r with 2. So 4 choose 2, 2 to the power 2, k to the power 2, and negative 1 to the power 4 minus 2. Okay, so that's our coefficient. So let's figure out what 4 choose 2 is. So 4 choose 2. So in your calculator, this has that NCR button. That's how you do this. Okay, so 4 choose 2 is 6. 4 choose 2 is 6. So 6 times 2 squared is 4. 6 times 4 is 24. Negative 1 squared is 1. So 24k squared. And that is our value for B. Okay, so again, in the comments, if you found a different solution or a different way to solve this, please let me know. It'll be interesting to see. But this is my go-to method of solving a binomial expansion. All right. Now, given that a plus b is 216, find the possible values of k. Okay, so a is 80k to the power 4 plus b, which is 24k squared. 24k squared is equal to 216. What we see, this is going to be a quadratic trinomial, so I'm going to bring the 216 across, equals 0. And let's see if we can simplify this a bit. So can we divide all of this by 8, maybe? Let's see, can we divide 216 by 8? Yes, okay, let's divide everything by 8. So that's going to give us 10k to the power 4 plus 3k squared minus 27 equals 0. And then we can either factorize this or use completing the square or use the quadratic formula. I'm just going to use the quadratic formula and say that k squared is equal to, and that's actually, it looks like a 15 and 18. That could work here to give us the solution. So let's see, let's use the quadratic formula and get to our answer, and then we can try the factorizing as well. Okay, so negative b plus or minus square root of b squared minus 4ac. So 10 times 27 is 270, times 4 is 108. So 10, let me again do this on the calculator, times, that's not times, where's the times button? Times 4 times 10, 1080. Okay, so plus 1080, and the plus is because it's 4 times minus 4 times that, so minus minus makes a plus. Okay, over 2a, 2 times 10 is 20. Alright, so that gives us k squared equals, so negative 3 plus, let's check the square root of 1089 is 33. So we've got negative 3 plus or minus 33 over 20. That gives us k squared equals, okay, negative 33 minus 33 is negative 36 over 20, or k squared equals negative 33 plus 33, or negative 3 plus 33 is 30 over 20, which is 3 over 2. And this one, you can simplify a little bit further. You can divide both of these by 4, so negative 9 over 5. Okay, now this one, no real solutions, because just taking the square root of a negative number will not suffice, so no real solutions here. I'm just going to do that, no real solutions. But this one, k is then equal to plus or minus the square root of 3 over 2. And that is our answer there. Let me just enclose that in a box. Okay, so you see how we did that? We saw this was a quadratic trinomial because this exponent is double that exponent. So that's how we know it's a quadratic trinomial. If the variable, one of the variables has double the exponent of the other one, and there's no other ones there. So it's the same as like 80k squared plus 24k, or 80k to the power 6 plus 24k cubed. Both of those would also be quadratic trinomials. All right, question 4. Prove this identity. Okay, so I see we're adding or subtracting fractions, so we want a common denominator, so I'm going to start with that. So common denominator of sine theta minus 1 times 1 plus sine theta, or sine theta plus 1. Okay, and at the top, I have lots of things to do there. So at the top there, we've got sine cubed theta has to be multiplied with 1 plus sine theta. Minus, here we've got sine squared theta, and that has to be multiplied with sine theta minus 1. Okay, so this is the left-hand side. Let's just write that down. Okay, now at the top here, we can see we can factor out a sine squared theta. So I'm going to do that. I'm going to factor out sine squared theta. And then what's left? Sine theta multiplied in here. Well, let's do all the steps. Let's not skip anything. So sine theta times 1 plus. Let me just do a better bracket. Times 1 plus sine theta. Minus, and then this sine squared theta is gone. So what's left is just this bracket, which is sine theta minus 1. And then all of that still over this sine theta minus 1, sine theta plus 1. So that's just going to turn into sine squared theta minus 1 if we multiply that out. And usually we don't want to multiply out the bottom, but in this case it's not part of the answer here. So it might be nice to do that in order to see that this looks similar to one of the identities we know, which is sine squared plus cos squared equals 1. And we'll get to that shortly. Okay, then so sine squared, let's keep the sine squared theta there. And then what's left, if we multiply this in, we get sine theta plus sine squared theta plus sine squared theta, and then minus sine theta, and then minus 1 is plus 1. All right, and at the bottom, we've still got this sine squared theta minus 1. Good. Now at the top, sine squared theta, and inside the bracket, sine theta minus sine theta cancels out, so we've got sine squared theta plus 1. sine squared theta plus 1 over, and now sine squared theta minus 1 is the same as negative cos squared theta. Negative cos squared theta. And sine squared over cos squared is tan squared. So negative tan squared theta. And then in the bracket we're left with a 1 plus sine squared theta. And I just switched this around because that's what this final answer wants. Alright, so there's our solution. So basically what we did, normal things of how to add or subtract fractions, get a common denominator. Then we just factorized at the top, simplified the brackets inside, and we used our knowledge that cos squared theta plus sine squared theta equals 1, this identity that we know. So if we were to move things around a little bit, to say, let's take the 1 over here, so it becomes negative 1 plus sine squared theta equals, if we take the cos squared over, it becomes negative cos squared theta. So we saw that this is equal to that. This is equal to that. So that's basically what this came down to. Alright, let's move on to the next question. Yo, it's a lot of space here. How many marks was this? Only 4 marks. Okay, that's fine. Hence, solve this equation. Okay, so this is exactly the same as the top, right? This sine cubed over sine minus, sine squared over 1 plus. Sine cubed over sine minus, minus sine squared over 1 plus. Yeah, okay, that's the same. So we have to show this is equal to that. Or what we have to solve this. So this part we can rewrite as our answer previously, which was negative tan squared theta times 1 plus sine squared theta. So that's just rewriting this part. Okay, equals, and then they tell us equal to sine, or tan cubed, tan squared theta, 1 minus sine squared theta. Okay, so let's change the tan into sine over cos. That's also a very natural, normal thing to do. So negative sine squared over cos squared, 1 plus sine squared, equals, and here we've got sine squared over cos squared, times 1 minus sine squared, or that looks like a 3 and not an S, sine squared. Now let's multiply both sides by cos squared theta. So that just gives us negative sine squared theta, 1 plus sine squared, equals, and on this side as well, we've got sine squared theta, and then 1 minus sine squared. Let's multiply in. So this gives us negative sine squared theta minus sine to the power 4 theta equals sine squared theta minus sine to the power 4 theta. Alright, so these will cancel out. The negative sine to the power 4, if we add that to both sides, that cancels out. So we can take this one, or let's say keep 0 on this side, and then sine squared plus sine squared is 2 sine squared theta divided by 2, so we get 0 equals sine theta, or sine squared theta, and then take the square root, so 0 equals sine theta. Okay, and we have to solve between 0 and 2 pi, so that's just in the first revolution, so we don't necessarily need the whole general solution for all of this. So what we can do is we can just say theta equals, well, let's actually still do the reference angle. Reference angle equals arc sine of 0, and that is 0. Okay, so in our first quadrant, so for 0, we'll have in our first quadrant, we'll have the answer is just 0 plus k times 2 pi, etc. And in the second quadrant, the answer is 180 minus 0, or pi minus 0, which is pi. Okay, and we're looking for between, not including 0. So our only answer is going to be this one. So theta equals pi. So that's our only solution, because 0 is not included in our answer here, and neither is 2 pi. All right. Next up, question 5. The diagram shows a sector ABC of a circle with center A and radius R. Okay, as we can see there. The line BD is perpendicular to AC. BD perpendicular to AC, as they show us. And then the angle CAB is theta radians. Okay, all of that is shown in the diagram. Given that theta is pi over 6, find the exact area of BCD. Okay, so how we'll find BCD is we'll find the area of this whole sector, and then we'll find the area of this triangle and subtract that, right? Let's do some color coding for this. So I'm going to say, let's find the area of this whole sector. Whole sector, and now comes the freehand part, which is usually not that good. Okay, that's pretty decent. We're going to find that area, and then we're going to find the area of the triangle, this green area, and we're going to subtract that, and what's left is then going to be this area. Okay, so we're going to say the blue area equals, and there's going to be the pink area minus the green area. Okay, that's our plan. Okay, so let's find the pink area. So the pink area equals, okay, so that's the area of a sector. So sector area is just this angle over the full circle. So that angle is pi over 6. So pi over 6 divided by a full circle, which is 2 pi, times the area of a circle, which is pi r squared. Pi times radius squared. All right, let's simplify that a little bit. So pi and the pi will cancel. Pi over 6 divided by 2 is pi over 12. So it's pi r squared over 12. Okay, so that's our pink area. Then we're going to find our green area. So the green area is this triangle. So triangle is half times base times perpendicular height. Okay, so to find, so we're going to say let's do this. Let's say it's half times AD times DB. Okay, so to find AD, we can use this. So this is pi over 6. So cos of pi over 6 equals r over AD. So cos pi over 6 equals adjacent, which is AD over r. Adjacent over hypotenuse. So times by r, so r cos pi over 6. And cos pi over 6, we know that's square root 3 over 2. So r times square root 3 over 2, so root 3 over 2r. Okay, so that's AD equals AD. Then we also know to find DB, we can do again the same, we can use sine. So we can say sine pi over 6 is equal to BD or DB over r. So again, that's going to be r times sine pi over 6. Now sine pi over 6 is a half, so a half r equals dB. So this gives us that the green area, or the area of the triangle, equals half times AD times dB. Okay, and that simplifies to, that's going to be over 8, so root 3 r squared, root 3 r squared over, let me just write that a little bit better, root 3 r squared over 8. Okay, so that's our green area, and our blue area is just the difference between these two. So our blue area equals pink area, so pi r squared over 12 minus our green area, root 3 r squared over 8. Okay, so let's simplify that. So we can get this all over 24. So it's going to be 2 pi r squared minus 3 root 3 r squared over 24. Okay, so that's one way you could have it. You could still factor out an r at the r squared at the top if you like. So r squared 2 pi minus 3 root 3 over 24. That'll be fine. This should also be fine. Any of these should be fine. Most important part is to recognize you can find the area of the sector minus the area of the triangle, and that gives you this area BDC or BCD. All right. Now given instead, okay, so given instead means we can no longer assume that theta is pi over 6, right? That was just for question A. Now instead of giving that, they give us that the length of BD is root 3 over 2. Root 3 over 2. Okay, so let's erase all of this. And they tell us BD is root 3 over 2. Okay. R, sorry, times R, root 3 over 2 R. Find the exact perimeter of BCD. Okay, so this perimeter, so we need DB, well, let's say CD plus DB. So we need CD plus DB plus BC. Okay, so let's colorize these again, color code them. So let's do DB in green, and let's do this one in red. All right. So CD is going to be AC minus AD. Okay, so CD equals AC minus AD. AC minus AD, yes, that's CD. Okay, so AC, we know that's R, and AD is root 3 over 2 R. Oh no, it's, sorry, R cos theta. R cos theta, right? We don't know what theta is, but first we can find out what theta is. So let's find out what theta is. So we could say, okay, yeah, let's start with that. Let's start finding theta. Okay, so to find theta, we can use the two pieces of information we have. We can do sine. Sine theta equals root 3 over 2R over R. So sine theta equals root 3 over 2R over R. Okay, so the R's will just cancel out. So sine theta equals root 3 over 2. So that gives us theta is the arc sine of root 3 over 2. So that gives us theta is pi over 3. Okay, so theta is pi over 3. So this distance here is then cos pi over 3 equals AD over R. So cos pi over 3 equals AD over R. So that's going to be R times cos pi over 3. Cos pi over 3 is a half. So that's a half R. Half R. So that just gives us a half R. Okay, R minus half R is a half R. So that's CD. Okay, then DB. DB, we're told, is root 3 over 2 R. And then BC. BC. Okay, so that's the sector area, arc length. So arc length of this sector. So we're going to say pi over 3 over the full circle. Oops. So pi over 3 over the full circle, which is 2 pi, times the circumference of the full circle, 2 pi r. Okay. So we can say pi cancels with pi, 2 cancels with 2, so pi over 3 times r. Pi over 3 r. Okay, and now we just add these three together. So that's just going to be, so CD, r minus, or sorry, CD is a half r. So half r plus root 3 over 2r plus pi over 3 r. And that is completely fine. If you want to make it into a single fraction, you can also do that. So that's going to be a common denominator of 6. And we're going to have 3r plus 3 root 3r plus 2 pi r over 6. Okay, so both any of these will suffice for a final answer. Okay, success. Next, new question. Okay, the function f is defined as follows. Find an expression for the inverse function. Okay, so to find the inverse, we're going to swap x and y around. So at the moment it says y equals, so we're just going to swap x and y. We're going to say x equals y squared minus 4 over y squared plus 4. Then multiply both sides by the denominator. So we'll get xy squared plus 4x equals y squared minus 4. Now we want to collect all the y terms including a y on one side. So we'll have xy squared minus y squared equals negative 4 minus 4x. And then factor out like y squared. We're left with x minus 1 equals negative 4 minus 4x. And then we'll divide by the x minus 1. So y squared equals negative 4 minus 4x over x minus 1. And now if you don't like the negative and the minusing at the top, you can just swap that around as well by saying let's take the negative from the top to the bottom. So at the top we'll then have 4 plus 4x or 4x plus 4. And at the bottom this will change around to 1 minus x. So if you like that more, I do, then that's also fine. And then finally we have to take this square root. So y equals the square root of 4x minus 4, or 4x plus 4 over 1 minus x. And if you wanted to, you could also factor out the 4 here and take it a bit further, but this I think is fine. Okay, and this is only for x greater than 2. So if x is only greater than 2, what would this look like? Would this have any limitations on it? Well, let's see. What would the domain be for this? I mean, the range be for this if x had to be bigger than 2. Okay, so let's say if x was 2, then we'd have 0, but for the range. Anything bigger than 2, then we get something like, let's say 3 squared minus 2. That's going to be positive. This is also going to be positive. So anything here, that's going to be all be positive, right? So our range would just be positive. So this means this domain must just be positive. So this is also for the x being positive. So the domain of the inverse is the same as the range of the original function. All right. Now show that this can be expressed as that. Okay, that should be. Oh, and hence state the range of f. Okay. So, yeah, for this, I mean, this range is actually, there's more to it than just this, right? But let's just keep it like that for now. Okay, so this one, let's get a common denominator for this. So common denominator would be x squared plus 4. So the 1 still has to be multiplied with x squared plus 4 minus the 8. So multiplying that in, we get x squared plus 4 minus 8 over x squared plus 4. And x at the top, 4 minus 8 is negative 4. So x squared minus 4 over x squared plus 4. So now we've shown that this is equal to that. Hence state the range of f. Okay. Well, for the range of f, okay, so we've already, let's do it like this. So we know it's for x greater than 2, right? So if x equals 2, then we have 2 squared minus 4 over 2 squared plus 4, which gives us 0 over 4 plus 4 is 8, which is 0. Okay. Now if we go a bit bigger, so this is the smallest value that we could have, right? Is if x was just bigger than 2. So if it's just bigger than 2, we'd have something just bigger than 0. Okay, so we know that f is going to be somewhere bigger than 0. And we might, and let's see, maybe there's also a maximum limit. So let's see if we increase x by a lot. Well, let's first try something just for interest's sake, like x equals 5. Okay, so So if x equals 5, then we'd have 5 squared minus 4 over 5 squared plus 4. So that'll give us 25 minus 4 over 25 plus 4, 29. Okay, so this is something, it's still less than 1, right? So that's still less than 1, but it's also bigger than 0. Now let's say if we make it a lot bigger, so if x equals, let's say, 100, what do we get then? 100 squared minus 4 over 100 squared plus 4. So that gives us 9,996, I believe, over 10,004. So this is still less than 1, right? But it's getting closer to 1. So that's the idea. So the limit of x squared minus 4 over x squared plus 4 as x approaches positive infinity is 1. So it's getting closer and closer to 1. So for any value greater than 2, it's going to approach 1, but it's never going to reach 1. So that is our range then, just that. Okay, again, if you found a different way to do this instead of just showing this limit idea, please let me know in the comments. It'd be interesting to see. Explain why the composite function f of f cannot be formed. Okay, so the range of f is from 0 to 1, but the domain of x of f is greater than 2. So, and since we're taking f of itself, this will not work, right? So the range of f does not contain its domain. That should be fine to say something like that, like part or all of the domain. It should be fine to say. But with this one, I mean, yeah, go play around with it a bit and check what happens if you try to do this. Go play around with it. Maybe if you have got graphics calculators or some graphical thing that can show you the graphs, maybe plot the graphs and see what happens, and see why this can't work, just to get a better feel for it than just the range of f does not contain its domain. But that is the issue. The range and the domain do not fit together here for this, and since we're taking the same function, they should. Question 7. Okay, here we have the diagram with the equation y equals 3x minus 2 to the power half. I get that. This one, yes, and we've got a line, a straight line like that. Curve and line intersect at a and b. Find the coordinates of a and b. Okay, so that's just solving simultaneously for these two equations. So that means we've got 3x. How will we do this? I'm just thinking now. So 3x minus 2 to the power half. Let me just rewrite it in this form for now. Equals a half x plus 1. Okay, so to the power half. So we can square both sides here. So let's square both sides. And that'll give us 3x minus 2 equals, and then a quarter x squared plus x plus 1. Okay, so 0 equals a quarter x squared. X minus 3x is minus 2x, and then 1 plus 2 is 3. And now I'm just going to multiply by 4 to get everything as integers. So multiply by 4, that gives us x squared minus 8x plus 12. Okay, now we can factorize this. So it's going to be x and x. We're going to have minus 6 and minus 2. Minus 6 times minus 2 is positive 12. Minus 6x minus 2x is minus 8x. So that gives us x equals 6 or x equals 2. Okay, so those are the x coordinates. So for the coordinate a, we know that's going to be the first or the smallest x value. So that's going to be 2 for x. And then to find the y value, we can substitute that into any of the equations. I'm going to use the straight line. So y equals a half times 2 plus 1. The half times 2 is 1, 1 plus 1 is 2. Okay, so a has the coordinates 2, 2. For b, the x coordinate is 6. So again, substituting here, y equals a half times 6 plus 1. Half times 6 is 3, 3 plus 1 is 4. We've got 6, 4 as the coordinates of B. Okay, and that was that. Hence, find the area of the region enclosed between the curve and the line. Okay, so to find this area, let me again use some color coding to show what we're doing here. So first we're going to find the area underneath the curved surface. Okay, so that's going to be this whole area. So we're going to find that whole area. Then we're going to find this area. And again subtract them. And what will be left will be this area. That's what's going to be left if we take the blue area minus the green area. Okay, so let's say that again. We're going to find the blue area minus the green area. And that's going to be equal to the red area. Okay, let's do this. Okay, so the blue area is the area underneath this curve. So we're going to integrate this from 2 to 6. Okay, so for the blue area, we're going to integrate from 2 to 6 this function, 3x minus what? 3x minus 2 to the power half. 3x minus 2 to the power half with respect to x. Okay, and then for the green area, let's write that down as well so long. So for the green area, we're going to integrate also from 2 to 6, but now we're going to integrate the straight line, which is half x plus 1. Going to integrate half x plus 1 also with respect to x. Okay, so let's do the blue one. So integrating this, let's use the chain rule. So we add 1 to the exponent and then we divide by the new exponent. So divided by 3 over 2, which is the same as timesing by 2 over 3. So I'm just going to write it like that. Okay, and then we also divide by the derivative of the inside. So if we differentiate this inside part, 3x minus 2, if we differentiate that we get 3, so we also divide by that 3. Alright, and now the green part, or let's just write, we also still have to write, we're doing this from 2 to 6. Over here, we integrate this, so adding 1 to the exponent, so we've got half x to the power 2, and then divide that by 2. Alright, and if we integrate 1, we get x. Okay, so this part I'm just going to half divided by 2 is a quarter, so I'm just going to write that as a quarter, x to the power 2. Alright, and again we're doing that from 2 all the way up to 6. Okay, so substituting in 6 first, that gives us 2. Well, let's do square brackets for this. Okay, so 2, 3 times 6 minus 2 to the power 3 over 2 all over 3 times 3, which is 9. Minus, and then we substitute in 2. So that's going to be 2 times 3 times 2 minus 2 to the power, where am I now? 3 over 2. All of that over 9. Okay, so 3 times 6, 18 minus 2 is 16 to the power 3 over 2. That's going to be 64, right? Let's just make sure. 16 to the power 3 over 2. That's 64, yes. Okay, so 64 times by 2 and divided by 9. That gives us 14 and 2 over 9. Well, let's just keep it in fraction form. I'm going to say 64 times 2 at the top, so 128 over 9. 128 over 9 minus, and then here we've got 6 minus 2 is 4 to the power 3 over 2. That's going to be 8, I believe. Let's just make sure. 4 to the power 3 over 2 is 8, yes. So 8 times 2 is 16 at the top and 9 at the bottom. So 16 and 9. And then 128 minus 16. Let's again just do this. Minus 16. It's 112. Can that divide by 9? No. It's 112 over 9. 112 over 9. That's the blue part. Green part. Okay, so let's substitute in the 6 first. So that's a quarter of 6 squared plus 6 minus, now we've got a quarter of 2 squared minus plus 2. Okay, so it's 6 squared is 36, divided by 4 is 9, 9 plus 6 is 15. And here we've got 2 squared is 4, times a quarter is 1, 1 plus 2 is 3, so that gives us 12. Okay, so then the red area, the final solution, oopsie, need to get rid of this. The red area is the blue area minus the green area. And the green area, 12 times 9 is 84, right? 12 times 9, oh, 108, sorry. Minus 108 over 9, so that equals 4 over 9. Final answer, units squared. Okay, so you're happy with what we did? We just integrated, found the whole area under this one curve minus the area under the other curve. That gives us the area between the two curves. Okay, again, if you found a different way, let me know. Next up, the curve y equals sine x is transformed to this curve y equals 4 sine half x minus 30. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations are appearing. Okay, so usually what we want to do first is do any translations that happen. Okay, so this first was translated, right? Nothing up or down, but it was translated 30 units to the right. So translated by the vector, so it's 30 to the right and 0 up or down. So firstly that. And then we can work inside the bracket and see this here. So this is a stretch factor of 2 horizontally. So horizontal stretch, or stretch in the x direction, horizontal stretch by factor of 2. So it's basically shrunk by a factor of a half, which means it's stretched by a factor of 2. And then also there is a vertical stretch with a factor of 4. Vertical stretch or stretch in the y direction. Vertical stretch by a factor of 4. Okay, so that's basically what it comes down to. So you'll get marks for each of these things and if you got the right order. So start with the translation and then do the stretchings afterwards. All right. Find the exact solutions for this. Okay. So let's first divide both sides by 4, which will give us sine of half x minus 30 being equal to, if we divide this by 4, we get root 2 over 2. Okay, now we can find our reference angle, which is the arc sine of root 2 over 2, and that is 45 degrees. So we're working in degrees here. You can see degrees. So we had sine of something with a positive value, so we're going to be working in the first and in the second quadrant. So in the first quadrant, our angle, which is a half x minus 30, is equal to, and again it's just in the first revolution, right? So we don't really have to do the whole general solution thing. Half x minus 30 equals 45. Now usually we would say plus k times 360, where k is an integer, so that'll give us all the possible solutions. But for this, it's fine if we just say equal to 45 in the first quadrant. And then take over the 30, so half x equals 45 plus 30, which is 75, and then times 2, so x equals 150. And then for the second quadrant, we have our angle, half x minus 30, is equal to 180 minus 45. So that's 135. Okay, so again we take over the 30, that gives us 165, and then multiply by 2. What is that? 330. Alright, so those are the only two angles between 0 and 360 degrees. Nice. Question 9. How many questions do we have left? 9. Still quite a few. Okay. Whoa. Alright, I'm just going to take a quick break here. I'm going to pause. Just pause this recording. Where's the pause button? Okay. We are back. So the next question, the equation of a curve. Let's just, what color we used previously? Let's switch to blue. Okay, the equation of a circle is this. Find the coordinates of the center of the circle and the radius. Hence find the coordinates of the lowest point on the circle. Okay, so we're going to be doing completing the square or something similar to that over here. So let's collect the x terms together first, just to show what it's like to have all the x's with each other, and then the y's with each other. So y squared minus 2y. And then I'm going to take over the negative 26 to the other side to become positive 26. So for this, we're going to rewrite the first two terms, x squared plus 6x, add half of 6 squared, so 6 over 2 squared, so 3 squared would be 9. Okay, so here we have 26, so on the other side we also have to add 9. Then with the y's, write those two terms and add half of this squared, so half of negative 2 is negative 1, and if we square that we get 1, so we have to add 1 here as well. Okay, now the reason we did that is this makes a perfect square. We can factorize that into x plus 3 squared. Plus, and the same here, y minus 1 squared equals, and then 26 plus 9 plus 1 is 10, 26 plus 20 is 36. So that is our solution, right? So the center of the circle is just the negative value of this, so it's going to be negative 3 and the negative value of negative 1, which is positive 1. So that's our center. And our radius equals the square root of 36, which is 6. Okay, so just to give an overview again, this is x minus a squared plus y minus b squared equals r squared. That's our general formula for the circle, for the equation of a circle, where the center in this case would be a and b, so we can see the opposite sign of what was in there, and the radius would be equal to r. Okay, so that's where we get this from. So now, since we've got a circle, let me actually draw a circle just to show what we're doing here. So we've got some circle there with the center here, which is negative 3, 1, and a radius of 6. So if we go, the lowest point of the circle would be going straight down from there. So if we go from this point 6 down, we end up at negative 3, and 1 minus 6 is negative 5. So that's going to be the lowest point. Lowest point of the circle will be negative 3 and negative 5. Alright. Now find the set of values of the constant k which align with this equation intersects the circle at 2 points. Okay, so let's write our circle equation first again. So our circle equation is x plus 3 squared plus y minus 1 squared equals 36. And we also have y equals kx minus 5. So to find the points of intersection, we're going to set them equal to each other. So we can just substitute this y value here into this equation. And that'll give us x plus 3 squared plus, and then y is kx minus 5. So kx minus 5 minus 1, so minus 6 squared equals 36. Alright, let's multiply this out. That's going to give us x squared plus 6x plus 9 plus k squared x squared minus 12kx plus 36 equals 36. Okay, so let's combine all the x squared terms. So for the x squared terms, we've got k squared plus 1 x squared, right? So that's these two taken care of. And now the x terms, so that's going to be the 6 minus 12k. Okay, 6 minus 12k x, and then the 36, and these 36 cancel out, and then we've got plus 9 equals 0. Alright, so we see this is a parabola, and we want intersection at two distinct points. So for 2 points of intersection, our delta, which is b squared minus 4ac, 4ac, that must be bigger than 0 if we want 2 distinct points of intersection. So let's just plug that in. So our b value, so b squared, 6 minus 12k squared, minus 4 times a, which is k squared plus 1, times c, which is 9, must be greater than 0. Okay, again, let's multiply everything out. So that gives us 36 minus, 12 times 6 is 72, times 2 is minus 72k, plus, 72 minus times 2 is 144. So 144k, plus, and then 12k squared is 144k squared. And then 4 times 9 is 36, so minus 36k squared, minus 36. Greater than 0. Collect like terms, so 144k squared minus 36k squared is 108k squared. And then minus 144k. And then the 36 minus 36 cancel out. So greater than 0. Let's see if we can simplify this. Divide both by 36. So that's going to give us then 3k squared minus 4k greater than 0. Factor out a k. Leaves us with 3k minus 4 in the bracket, bigger than 0. And now what we want to do not do this. Do not say, now we can say that k is greater than 0 or 3k minus 4 is greater than 0 and then simplify from there. That is incorrect. So what we want to do is we want to find our critical values, which is the same as if this was equal to 0. So we'd say for critical values k is 0 or k equals 4 over 3. But then we draw a little diagram just to show what we're looking for. So these critical values are x-intercepts in some sense. So it's going to be at 0 and at 4 over 3. So at 0 and at 4 over 3. And we're looking for, where is this graph that we have here greater than 0? So it's this arm from there and this arm from here, right? So it's everything to the left of 0 and everything to the right of 4 over 3. So our solution is k is less than 0 or k is to the right or greater than 4 over 3. And that is our solution. All right. Next question. Wait, where am I now? Here. Okay, the equation of a curve is such that the second derivative equals this, and the curve has a stationary point here. Determine the nature of the stationary point. To find the nature, we want to determine if it's a maximum or a minimum value. So we substitute this x value of the stationary point into this second derivative. Okay. So we have 6 times negative 1 squared minus 4 over negative 1 cubed. So basically we're just looking for, is this positive or negative? So let's just get the answer. Negative 1 squared is 1 times 6 is 6. And then negative 1 cubed is going to be negative 1. Negative negative makes it positive 4. So that's going to give us 10. Now 10 is positive, which means that we have, if we have a positive value there, that means we've got a minimum stationary point. So that's a minimum stationary point. Okay, good. Now find the equation of the curve. So let's basically just do this again. So if we have a second derivative of some value being positive, that means a minimum stationary point. And if we've got a second derivative of some value being negative, that means we've got a maximum stationary point. So this is important to know. Now find the equation of the curve. Okay, so to find the equation of the curve, let's first find the first derivative. So the first derivative, dy dx, is going to be equal to the integral of the second derivative of this, 6x squared minus 4x to the power negative 3 with respect to x. Okay, so if we integrate this, we get 6x cubed divided by 3, so that's just 2x cubed. And here we've got 4x to the power negative 2 divided by negative 2, so plus 2x to the power negative 2. Let me just make sure that's correct. So 4x, add 1 to the exponent, divide by the new exponent, so that's going to be negative 2, and there's negative in front, so it's going to be plus. Yeah, that's right. Okay, and then plus some constant, c or k, whatever you want to call a constant. Now to find that constant, we can substitute a point in that we know. So we know at the point x equals negative 1. So substitute the point, when x is negative 1, then the derivative, the gradient, is 0, because that's where it's a stationary point, right? So that means the gradient is 0 here. So we can substitute that in, so 0 equals 2 times negative 1 cubed plus 2 times negative 1 squared plus c. So that gives us 0 equals negative 2 plus 2 plus c, so 0 equals c. Okay, so that's our first derivative, it's just this. So to find our y value, our function, we're going to say that's the integral of the first derivative. And our first derivative was 2x cubed plus 2x to the negative 2 plus 0. With respect to x, we're going to integrate that. So that gives us, integrating this, so 2x to the power 4 divided by 4, so that's going to be a half x to the power 4. This one, let's do this again in rough work here. So add 1 to the exponent, divide by the new exponent. So that's going to be negative 2x to the negative 1. So minus 2x to the negative 1. And then plus c. Okay. Now we can substitute a point that lies on the curve, because this is now the curve, the function, which is the point negative 1 and 9 over 2. So we're going to substitute the point negative 1 and 9 over 2 into our equation. The 9 over 2 equals a half times negative 1 to the power 4 minus 2 times negative 1 to the power negative 1 plus c. Okay, so that gives us 9 over 2 equals negative 1 to the power 4 is just 1, so that's just a half. Negative 1 to the power negative 1, well, that's the same as 1 over negative 1 to the power 1. So that's the same as 1 over negative 1, which is just negative 1. That's going to be plus 2 equals, plus c. So let's take everything over. 9 over 2 minus half is 8 over 2, which is 4. And then 4 minus 2 is 2. So 2 equals c. And then finally we have our equation. Y equals a half x to the power 4 minus 2 over x plus 2. And there we have it. That is the equation of our function. Equation of the curve. Okay, good. Question C, show the curve has no other stationary points. Okay, so let's just write down our first derivative again. So our first derivative was 2x cubed plus 2 over x squared. So 2x cubed plus 2x to the power negative 1. Well, I'm just going to write it like this, 2 over x squared. Now to find a stationary point, we're going to make the derivative 0, right? The gradient must be 0 there. So let's see what happens if we do this. Over x squared. Let's multiply everything by x squared. So 0 times x squared is still 0. This becomes 2x to the power 5. And this becomes just 2. Okay, so take the 2 over. So negative 2 equals 2x to the power 5 plus nothing. And then divided by 2, negative 1 equals x to the power 5. And if we take the fifth root, then we just get x equals -1 and no other solutions. So that is the only solution, nothing else. So only this one, that's the only stationary point when x is -1. Alright, now question D. A point A is moving along the curve and the y coordinate of A is increasing at a rate of 5 units per second. Okay, so that is basically our dy dt, like with respect to t. That's 5. Okay. Now find the rate of increase of the x coordinate. So we're looking for dx dt. We're looking for that. Of A at the point where x equals 1. So let's find, so let's see, so dx dt is equal to dx dy times dy dt. Okay. So to find dx dy, and we're looking at it at the point where x equals 1, right? So let's find, so dy dx equals, so let's find that dy dx 2x cubed plus 2 over x squared. So that's 2x cubed plus 2 over x squared. But now at the point where x equals 1, we'll have 2 times 1 cubed plus 2 over 1 squared. So that gives us 2 plus 2, which equals 4. So dy dx equals 4 at this point, which means dx dy is just the other way around. That equals 1 over 4, right? So this is 4 over 1, this is 1 over 4. So dy dx is 1 over 4. I mean dx dy. Okay, so dx dt equals dx dy at this point, 1 over 4, times dy dt, which is 5. So that equals 5 over 4. Okay, if you didn't understand what just happened here, the main important part is this, right? We can use the chain rule idea here. The x dt, the increase of x with respect to time, is this, because dy and dy will cancel out, and we've got dx dt. So that, if you understand that part, you're well away. Because now dx dy is just the inverse of dy dx. So dy dx, at the point 1, we found was 4 over 1, so then dx dy is just the other way around. You could have also said, from here, dx dy equals 1 over 2x cubed plus 2 over x squared. And then simplified from there, right? And then just substitute 1 in this simplified answer, or just substitute 1 directly in here. Use your calculator, so something like 2 times 1 cubed plus 2 over 1 squared, and then you'll get 1 over 4, right? Same thing. All right. Okay, that was it. That was the last question. So I hope that was useful. And again, let me know if you found any other ways or different ways or faster ways, or any ways that made more sense to do any of these questions, and then I'll see you again for the next paper.